Today we're talking about perfect squares and square roots. So we're just going to define what a square is and what a square root means that you're doing to a number. So to find the square of a number, you must multiply that number by itself. So it means that you're raising it to the second power. But we say taking the square of a number just means that you're going to be multiplying it by itself one time. So an example would be 6 squared, or 6 to the second power. You're multiplying it by itself, so 6 times 6, and that equals 36. So when we get the squares of whole numbers, they're called perfect squares. They're perfect because if you were drawing out a representation of them, their side lengths would be perfect whole numbers there, and their areas would be whatever you get when you multiply the side lengths by each other. So we have our first 20 perfect squares listed here. I want you to pause the video and see if you're able to fill in any of these, and then once you're ready you can go ahead and press play to check to make sure that you filled them in correctly. Alright, hopefully you paused the video and were able to fill in most of these. Some of the higher ones might have been unfamiliar to you, but this is our list of the first perfect 20 squares, and we would get them by taking each number and multiplying it by itself. So for example, when we got 4 squared equals 16, that's because 4 times 4 is 16. Later on to the big numbers, we would see that like 14 squared would mean 14 times 14, and if you multiply that out, that would be 196. So there's the first 20 perfect squares. You will be expected to memorize those, and if you ever forgot how to do it, you could just multiply two numbers together. So if you forgot what 15 squared means, you could use the multiplication algorithm or any other ways that you know how to multiply. So however you would want to do that. In our next definition, we have the square root of a number is one of its two equal factors. To find the square root, you must find which whole number multiplied by itself is equal to the number that's under the radical. And that symbol that we have there is called a radical, and it symbolizes that you're taking the square root of a number. So for example, if you saw the square root of 25, we would know that 5 times 5 is the same thing as 25, so we can rewrite it under the radical as that. 5 times 5 means you're doing 5 squared, and then once you have a radical and a square, you can say, well, those are opposite operations, so we can cancel them out, and we're left with 5, and that's just saying that 5 is the square root of 25. So that just is one of its two equal factors, and if we drew out a square that had an area of 25, then both side lengths would be 5 long. So we have a couple examples here. If you want to pause the video and try them on your own, you're more than welcome to. If you feel like you want some more guidance, you can just keep listening. So when we want to take the square root of 16, we know that that can be rewritten as the square root of 4 squared, because 4 times 4 gets us 16. The opposite of squaring a number is taking the square root, so those two operations cancel each other out, and we are left with 4. So 4 is the square root of 16. For the square root of 256, we know that that is the same as the square root of 16 squared, because 16 times 16 is 256. Those two operations cancel each other out, so the square root of 256 is 16. And then in this last one, the square root of 144, 144 is the same as 12 squared. Taking the square root of 12 squared cancels the square root and the square, which leaves us with the square root of 12 for 144. So then on the bottom, we're just kind of doing the opposite. We're squaring the number. So 17 squared means you're multiplying 17 times 17. And you might either remember it, you might have to multiply, or you can look at your notes above, and we see that 17 squared equals 289. 6 squared means you're doing 6 times 6, and 6 times 6 gets us 36. And in our last example, we had 10 squared, and 10 squared means you're doing 10 times 10, and 10 times 10, sorry, I can't write tonight, equals 100. So there's your examples. Make sure that you have all of those perfect squares written down correctly so that you have somewhere to study off of them.